Okay, so if you need to graph this rational function, Desmos wants you to graph it by putting in some specific points. So let's you can graph any function by doing this. You can make yourself a table of x and y values. Okay, plug in a value for x, whatever number you want, and see what it spits out for y. So if you plug in x equals 0, 0 plus 4 gives you 4. 4 over 4 makes 1. Okay, that's why I picked the number 0, because it's nice and easy to graph. And then you can pick some other numbers. I guess before we do that, though, let's quickly take a look at this equation. This is the same type of rational function. This one's just going to be shifted over a little bit, okay? Y equals 1 over x. So this graph looks like this if you plug it in a graphing calculator, okay? It's got two things. It's got a horizontal asymptote, which means it's like this line that never gets crossed by our graph as you go to infinity. And it also has a vertical asymptote. It never touches this vertical line right here. And that's because you can't plug in x equals 0, right? If you did, you'd have a divide by 0 error. So with graphs, when you're trying to find out asymptotes, look for vertical asymptotes, look for the number that would cause a divide by 0 error. And in this case, x equals -4 causes a divide by 0. So I'm just going to make a note on my graph. Make a dotted line. It's never going to cross here. It's going to get infinitely close to it, but never cross. Move that over a bit. Oh, of course it's going to do that. Let's move that back. Sorry. No, it's still doing it. Oh, it's because I have this backwards. Sorry. There we go. That's better. I didn't want to have all that black space. So we know it's going to have a horizontal line. So let's get back to plugging in some values. And the reason why I stopped and put that on there is because we want to have some points to the left and to the right of this dot, okay? So I plugged in x equals 0, I got y equals 1. If I plug in x equals -2, I'm picking that one because I see -2 plus 4 is going to make a 2 on bottom, and 4 divided by 2 makes 2, okay? So we got a -2, we got plugged in x equals 0. Let's plug in some points that are to the left. Let's plug in x equals -5, okay? -5 plus 4 makes -1, and 4 divided by -1 makes -4. And then -6 will work out great because that makes the bottom equal -2. And 4 divided by -2 makes -2. So we got some points now we can finally put in Desmos. Okay, so grab the pencil tool, go to 0, 1, and put a dot. Oh, actually, sorry, I think they first want asymptotes. So let's put this vertical asymptote at x equals -4. And then I actually haven't talked about this yet. It's going to have a horizontal asymptote at y equals 0. If you haven't tackled asymptotes yet, you always have an asymptote on the x-axis if the power is bigger in the top than in the bottom. So like, I don't know exactly what this function will look like when I graph it, but because it meets that rule where the power is bigger in the bottom, I know it's going to have an asymptote somewhere at y equals 0. Get infinitely close but never touch. Okay? So that's just a quick rule of thumb. If the power is bigger in the bottom of your function, then you will have an asymptote at y equals 0. So that's why I put that horizontal line there. And then again, the vertical line is there because we said that's the x value that would cause a divide by 0 problem. -4 plus 4 makes 0. Okay, so now we got that. I think Alex wants that before we try to do everything else. So we plugged in 0, 1. We got to plug in -2, 2. And then we're going to connect those. Oh, it wants 2 points on each side first. Okay, so let's plug in the -5, -4. And then we also have -6, -2. Okay. And then I think that's it. That's the graph that it wants. Okay, so you got to plug 2 points, one on the right, one on the left, make that vertical asymptote and make that horizontal asymptote, and it should graph.